And homework 10 is projectile motion and quadratic regression. So the first 5 problems are on projectile motion. Basically, it's just giving you this sort of upside down parabola where, something gets shot up and then it reaches a maximum and then it comes back down. So you guys have a handful of different types of problems that you're going to be solving, different questions that they're going to be answering or asking that you're going to be answering. So question number 1, it says a pumpkin is launched directly upwards 72 feet per second from a platform that's 24 feet high. So these two numbers, like this, the 72 feet, that's the initial velocity. That's always going to be right there in the formula. 24 feet is the initial height. That's always going to be right there in the formula. The negative 16 is actually the acceleration due to gravity. If you guys are physics people, that number should hopefully mean something to you, but this is what the formula is going to look like. Notice all of them have this negative 16. The initial velocity is always this number right here. The initial height is always this number right here. Not something that you'll have to create for yourself, but just so you know where that formula is coming from. So find the maximum height. Remember, if a parabola goes like this, it goes up, it goes down. The maximum height is a point on the graph called the vertex, and the vertex is something that we've worked a lot with these last couple units. So remember the formula is x equals, except this time we are going to use a t, because this is in terms of t rather than in terms of x. So t equals negative b over 2a. That's going to allow us to find the time when it's at a maximum, and then we'll sub it back into our equation so we can find the actual heights. So we've got negative b, which is the number attached to the t, so that's a 72 over 2 times a, and a is a negative 16. So when I multiply that by 2, I get negative 32. So this negative 72 divided by negative 32, you could plug that in if you wanted to. You end up with 2 1/4. So that means 2 1/4 seconds after being launched, the pumpkin is reaching its maximum height. But the height itself, like I said, remember you want to plug that back into the formula. So we are going to have h of t, which is now h of 2.25. We're going to take this equation right here and then replace the t's with 2.25. So 2.25 goes in right there. We square it, plus 72 times 2.25. And then plus 24. So I am going to plug those values into a calculator. Oh, sorry, my calculator's over here. There we go. Sorry, misplaced calculator. There we go. So we are going to take this expression, negative 16 times 2.25 squared, plus 72 times 2.25 squared, and then plus 24. So we sub that in, and this is the value we're going to get. All right, so we have 307.5 and that would be in feet. So that's your answer, and then the time that it takes to reach that point, that would be 2.25 seconds. Okay, so make sure when your problems have context like this that you're actually including what the units would be. All right, so that's our projectile motion example. We're going to look at number 6 on the next page for our quadratic regression example. All right, so equation for the curve of best fits. I am going to remind you of how to use Desmos to do that. Okay, so you're going to add a table. Now these, whenever you have years, it's always probably a good idea to turn your years into like 1-digit or 2-digit numbers. So we'll go with years after 1990. So 1, 4, 8. This would be 10 years after 1990, 15, and 18. Those will make our numbers much more manageable because otherwise they're going to be gigantic numbers. All right, so remember in Desmos, you are going to add a table, and we can start typing these values in. So our x values are the years that I wrote along top here. So 1, 4, 8, 10, 15, and 18. And then in this column, we're going to put those values for y that they have on the table. So 5,500, 6,200, 7,000, 7,200, 8,800, 9,600. All right, so you've got those values in there. The table is there. You're going to add another thing, and that's going to type in the regression equation. So you start with y1. Okay, so you can do that. And then you don't do an equal sign. You go into the stats functions right here, and you use this little tilde, that little squiggly right here. So you do standard form ax squared plus bx plus c, except you use x sub 1. So we use a times x sub 1 squared plus, and then back to the alphabet, b times x sub 1, and then plus c. So you've got just your normal standard form, except you use x1 and y1. So if we look here, we've got our parameters, a, b, and c. So we can use those. I'm just going to write them down myself. So our parameters, we have y equals. So for a, we're going to use that value that we just had on the screen. So we've got 4.462, and that's what's attached to the x squared. And then we have plus b was a 153.935 x plus, and then c was 5403.72. All right, so that is the equation that we're using for our quadratic regression. This said during what year will tuition and fees reach 15,000? Okay, so the tuition and fees, that's the y. So what you would do is you would take this and you would sub it in to the equation. Okay, and then this, we're definitely going to do quadratic formula for this equation. So we're going to get everything on one side. So we're going to do 0 equals, and we're going to subtract the 15,000 from both sides of the equation. And then we will sub it into the quadratic formula. All right, so you take that value right there, and then you're going to subtract 15,000 from it. So we have 5403.72 minus 15,000. And we end up with negative 96.28. And then these values, like I said, are going to go just right in the quadratic formula. So we have x equals negative b, so negative 153.935 plus or minus the square root of that same large value squared. So that's the b squared minus 4 times a times c. Close that big old square root and all over 2a. Okay, and this is something you would 100% just use a calculator for. All right, so let's start to type this in. So you've got negative 153. Actually, let me set up a fraction. Negative 153.935 plus, so we'll start with the plus version. All right, so we do that, and we end up with 32.23. We'll go with that. So we end up with x equals 32.23, and then we'll do the subtraction version. So remember, the trick with some of these is you can just copy and paste, and then I don't have to type this all out. I'm just going to paste it and replace the addition with subtraction. Okay, so that one's no good, the negative 66.73. So I'm going to write it down just so that I can tell you that that doesn't make any sense, because that would be going backwards, and chances are that, you know, in the 1920s, tuition was not $15,000. So this, remember what this number represents, it's years since 1990. So if you add 1990 and then go 32 years, you will land somewhere in the year 2022, which is right around the corner.